and the buff colored one, they go together. So I'm going to start on the pink one. So this works exactly like solving the square root problem, except this time, what am I taking? Not a square root, but a cube root. So instead of squaring it to get rid of it, we're going to cube it, right? So that's not hard at all. So first of all, is the radical by itself? The radical is by itself. Did you say no? What's with the radical? There's nothing else with the radical. Oh, Lord. So we're going to cube both sides. And just for the record, since I'm recording, 4 to the third is not 12. It is 64. 4 times 4 is 16 times 4 is 64. So I get 64. I'm going to add 1. So I get 13. Does it say to check it? Nope. We're not checking.
That's just it?
That's it. Like, that's it.
So why do we have another? So it's just
So example 2 is now this time, is the radical isolated? No. So this time, move the 1. To get rid of the cube root, I have to cube it. So I get 4x minus 13 equals 27. How many of us like this?
So far. Having fun.
This is good.
You got your hands up there?
Yes. Is there another one?
Yeah, example 3. It's 3.
There's one more?
Yep. You want to see it?
Yeah. Are you still copying? Okay. Shh. All right. Is the cube root, boys, is the cube root isolated? Yes or no? No. So the first thing I have to do is subtract 2. Now, the 2 that's in front, is that add, subtract, multiply, or divide? Multiply, what's the opposite of multiply? Divide. So I'm going to divide by 2. And then you can cube it. I think it's 125, is that right? Yes. All right, so cakewalk, right? We like this. This is easy. Yes, easy peasy. All right, so the next one is not any harder at all. I'm positive. I never lie. Stop laughing. Okay. So listen. When I took the square root of x, how did I get rid of the square root? I squared it. And the reason I squared it is because the square root is the same as x to the 1/2, right? So I flipped it. That's what I did. I took this, the 1/2, and I flipped it over, which is squared. It's 2 over 1. And when we did the cube root of x, how did I get rid of that? I cubed it. Well, the cube root is x to the 1/3. So to cube it, I flipped the 1/3 over and got 3. Okay? So what we're going to do, we are following exactly the same steps as we just did on the easy peasy. The last thing is, though, it's not going to be cube root or square root. We're going to get a fraction, and we're going to flip the fraction. All right? But it's easy. So if I'm raising x to the 4/5, reciprocal of 4/5 would be 5 over 4. Okay? So, we're going to start right here. X to the 4/3. To get rid of the 4/3, I have to multiply by the reciprocal. So, at x to the 4/3, so I'm going to raise this to the 3/4. And what I do to one side, I have to, right, these cancel out, and that becomes just x on this side. Now, I have x to the 3/4. So x to the 3/4, if I rewrite this, the 4 goes on the outside, and I have 3. So, what's the 4th root of 16? So, right. So, the 4th root would be 4 times 4 times 4 times 4. Well, that's too big, right? But 2 times 2 times 2 times 2, that gives me 16, right? So I get 2 to the 3rd power, which is 8. So what's the 4th root of 16? So what number times itself 4 times equals 16? So I'll tell you what, let's write a couple of these down. So first of all, 2 to the 3rd power is 8. 2 to the 4th power is 16. And 2 to the 5th power is 32. 3 to the 3rd power is 27. Somebody do 3 to the 4th. Oh, it's 81. Right? 81. Okay. And then 4 to the 3rd power. What is 4 to the 3rd power? 32? And then 4 to the 4th is 120. 256. Okay. So these are the common ones. All right. So these are your common ones. So when you're doing this, you probably want to look back at this if you're stuck. Okay. But these are the common ones. So what did we say was the 4th root of 16? 2, and it leaves me with the 3. So 2 to the 3rd is 8. So do the square. Yes. So you always want to do the square, do the radical first, because that'll make it a smaller number, and then multiply. So on number 2, this is the square root, right? So I have to isolate it. So I'm going to subtract 6. And then what do I do to get rid of the 1/2? By what? 2. So x is 12. Nope, it'd be -6 times -6. Because it's to the power of 2, not multiplied times 2. So this one, before you can do it, you have to rewrite it. So if I'm rewriting this, how do I rewrite that? 3 over 2. And then how do I get rid of the 3 over 2? Raise it to the 2 over 3. So we're going to raise this to the 2/3. So I get x minus 2 equals 8 to the 2/3. So 8 to the 2/3. The 3 goes out here, and this is squared. So what's the 3rd root of 8? 2 times 2 times 2, right? So I get 2 to the 2nd power, So x minus 2 equals 4. Add the 2. Yes? You guys are being difficult. Yes. How do I have to start this? Divide by the 12.
What? No, you have to divide by 12 because it's in the front. And then after you divide by 12, then you do the 5.
So first of all, we're going to divide by 12. Now, how do I get rid of the 1/5? So we're raising it to the 5th power, right? So I'm going to raise this to the 5th power and then take 2 to the 5th power. Right, these are easy. Okay, I do want to go back. Do you have a calculator? Does everybody have a calculator? Okay, everybody type in your calculator if you have the calculator. If you don't have one, get one. So the 16 to the 3/4. So watch.
That is so easy.
Okay. So if you take the 16 and you use the little caret thing, if you put in parentheses 3 divided by 4, it gives you 8. If you don't use the parentheses, you're going to get it wrong.
Miss Audrey showed us a minute ago.
Well, I think you guys are smart enough to do it without the calculator. But we have a backup now, okay? Okay. That's why your number's back there still, right? Yeah.
Dang. I thought we were having fun Friday.
We are having fun Friday. All right. So x plus 12 is raised to the 1/2. So we're gonna square it, right? Hey, stop yawning back there. So yes. So now what do I do? Move the x and the 12 because we're because now we can factor it, right? It is. It's exactly what we did yesterday. Well, you're doing it right now. Okay. You know, I've said this before. My husband and I do not sit at home on Friday night and square equations for fun, right? No. But what we do, this is, like, that's not what you do in life. I'm not going home and working the quadratic formula for fun. No. But my husband is a programmer, and he works at J.P. Morgan, and he programs. But do you know how much of his day he spends programming? About an hour. The rest of it is spent problem solving so you can actually do the programming. So the problem solving is what takes all day. The programming, which is the fun part, he gets to do like for an hour. And so it's learning how to think through problems. That's what's going to get you through life. And it's no matter what your job is, you have to problem solve. Nurses have to problem solve. Everybody problem solves. It's not just a math thing, it's a thinking thing. And that's why you're doing it. Not because this is super fun or not because you're going to do this again, right? But it's logical thinking. That's what you need to be able to do. And some of you need a lot of help with your logical thinking. All right. So that was enough. That was enough of my lecture for today. Let's finish the last one. We're almost there. Okay. So, but this is exactly what we did yesterday, baby. So, did you move the 5? So once we move the 5, so what is the 2 over 1? We're going to square both sides, correct? So now we're going to multiply. Once I multiply it all out and I combine like terms, now what do I do? Can we subtract the 3x and the 13 and then we're going to factor? I love your excitement though.